In this video, we're going to work through a triple force problem. And what we're going to try to do is take these three different vectors and add them together to find a resultant vector. We're then going to find the magnitude of the resultant vector and the direction of that resultant vector. So we have a dog walker, and the dog walker is walking three dogs fastened to separate leashes that meet in a connective hub, leading to a single leash that she is holding. So essentially, she's holding this leash, right? And there's a hub, and there are three different leashes that are coming out from it. So the dog walker is here, and then you've got three different dogs over there. Dog 1 applies a force of 8 newtons at 32 degrees. So let's say this is 8 newtons, and the angle here is 32 degrees. Dog 2 applies a force of 10 newtons at an angle of 110 degrees. And dog 3 applies 5 newtons at an angle of 280 degrees. Rounding to 2 decimal places, find the magnitude and direction in degrees of the resultant force when the three vectors are added together. What we need to do is we need to figure out what is our horizontal components, add those all together. What is our vertical components, and add all of those together. Horizontal components are x equals the magnitude of your vector times cosine theta. The vertical components are going to be the magnitude of your vector times sine of theta. So if I can find all of my horizontal components and add them together, and then find all of my vertical components and add them together, then I can find what the horizontal and vertical components of my resultant vector are. I like to do this by just creating a little table. You don't have to create a table. I like to make this my horizontal and this my vertical. And in the end, I just put what those add up to. So I'm going to start with dog 1. In dog 1, my horizontal component is going to be 8 times cosine of 32. Dog 2 is going to be 10 times cosine of 110. And dog 3 is going to be 5 times cosine of 280. So my horizontal components are like this, and I get those directly from this. So 8, 32, 10, 110, and 5, 280. Now I take my calculator. I'm plugging in degrees, so I want to make sure I'm in degree mode. And I say 8 times cosine of 32, close my parenthesis. Hope I've got something weird happening. 8 times cosine of 32 plus 10 times cosine of 110 plus 5 times cosine of 280. 4.23. That's how far the resultant vector will go in the x direction. That's how far these dogs are pulling the dog walker. Now our vertical is essentially exactly the same thing. The only thing that changes are these are going to be sines. So it's going to be 8 times sine of 32 degrees. 10 times sine of 110 degrees. 5 times sine of 280 degrees. So the only thing that changes is that sine. So we're going to do the same thing, except now we are going to use sine. I'm going to hit enter on there. And our dog walker is being pulled 8.71 units or newtons in the y direction. Those are our components: horizontal, vertical, x, y. The question asks us to find the magnitude and the direction. Now everything that we've done so far, our magnitude has been r squared equals x squared plus y squared. There's x, there's y. Our direction has been tangent is y over x. That's all we need. So to find our magnitude, we're going to do r squared equals 4.23 squared plus 8.71 squared. 4.23 squared plus 8.71 squared. And then we're going to square root that. Our magnitude, that's the notation for magnitude, is 9.68 newtons. Then we need to find our direction. Our direction, tangent of theta, is y, which is 8.71, divided by 4.23. That's our x. Y divided by x. Y divided by x. Inverse tangent that to get theta alone. 8.71 divided by 4.23. And we get 64 degrees. There's our magnitude and our direction. So when you're working out these problems, figure out what are all the forces. Find your horizontal components. Find your vertical components. Add them together. Then apply your magnitude formula and your direction formula.